Hey, Wiz, RC just dropped a next level open weights, no trade-offs, American made 4.5 billion, kind of small LLM. It's called AFM, the RC Foundation model. It looks like it's pretty dope, right?
You know what? It is pretty dope, Greg. And I think we have the right guy here today to tell us all about it.
Yeah, let's welcome Lucas Atkins, the CTO of Arcee AI, up to the stage. Lucas, can you just give us the super high level, the TLDR, AFM 4.5B, dropped yesterday officially?
Yeah, the elevator pitch. I've been working on this. I don't even think it'll be the perfect one, but thanks for having me on. First off, AFM we needed a model that we could serve the vast majority of our customers that was cheaper than the alternatives, that we had complete control over the license. So, we didn't have to worry about having to call it llama or something of that sort. And there's also a lot of really large companies that don't allow you to use models coming out of China. Their compliance departments won't allow it. Whether or not I agree with that doesn't matter. But what matters is that was a deal breaker. And so the available models to use at the size we were looking at were not, you had to go with something out of China to be competitive. So instead of kind of having a business model where we said, hey, let's wait for hopefully another large company to open source a model, let's just do it ourselves. So yeah, a small compact model that can compete at the frontier for a vast majority of your enterprise use cases.
So this is still an SLM in 2025, 4.5 billion.
Yeah, I think SLM. I think, we want to go even smaller for others. There's some use cases, especially when you're dealing with the absolute edge where you need to be even smaller. But 4.5B was where we thought we'd hit a sweet spot on a price to performance, ratio.
Nice. Well, thanks for the elevator pitch, Lucas. Wiz, I believe we have a demo teed up to look at both the base model. We're going back. We're going to check out a base model today, as well as the extremely trained and tuned 4.5B off-the-shelf model that we'll dig into all the details of. You ready to get started?
Yes. I'm ready to look at both a base model and an instruct model. Like we used to do so often.
Yeah. All right, guys, I'll see you back on stage in just a moment. Let's kick this thing off. We've got a lot of great discussions today. Welcome, everyone, to another AI Makerspace weekly YouTube live event. Today, we're covering AFM, the RC Foundation model. This is the first model drop from the RC Foundation model family. You'll learn directly from the guy leading efforts on training these models, as well as our resident expert, the Wiz, what exactly a state-of-the-art training pipeline looks like today in 2025 to build one of these things, from pre-training to mid-training to post-training, and how this kind of aligns with the current state-of-the-art in the world, and how it's in tune with exactly what people want across the globe in AI, as we've started to allude to already. If you got questions along the way, please go ahead and just smash directly live in the YouTube live chat, or on your viewing platform, just throw a comment and we'll get to any and all questions that we have today. So with that, let's go ahead and get into AFM 4.B, the RC Foundation model. Okay, so if you stick with us for the rest of the hour here, you'll learn about the AFM family and you'll really understand this state-of-the-art training pipeline, as well as lessons learned out there at the LLM edge, lessons learned by people training these models. You'll understand why you might want to choose a really small performant model like this, and we'll check out how the models actually look and feel coming up off the shelf, do a little vibe checking with the Wiz. So we're going to walk through kind of what we know from the blogs and the press release. There's a ton of technical detail here. We've done events on a lot of the things that we'll be discussing, but this is going to be full of trailheads if you're relatively new to training. And even if you're kind of an expert, there's still going to be some real nuggets here as we talk about the details, the nitty-gritty of what's really going on. First, the high level, though. The AFM family here is this idea that we got this great model and we can sell it to all these different customers across all these different use cases. It's got the performance and cost, it's got the flexibility, and it's got basically everything you want in one great little package. Okay, so that's what we're seeing from the outside. 4.5 billion parameters. We've got some instruction tuning. That does not do justice to actually what's been going on to bring these things to life. And you can run these on relatively small amounts of compute and do inference pretty quickly. So that's one of the real big takeaways here. The first thing I want to dig into is thinking about architecture. This was a blog that I thought was kind of cool, released just a few weeks ago from Sebastian Rashka, talking about the architectures of leading models today. This is the kind of thing that people who build models need to grok deeply and think about to make decisions and make trade-offs to really dial in the performance versus cost and the final product. These models, while they're structurally similar in a sort of decoder-only transformer sense, oftentimes they have specific aspects that are tweaked and dialed in differently. We're going to talk about two of those specific aspects first today. Key mods include grouped query attention and the ReLU² activation functions, replacing the SWGLU functions from presumably the last model that Arcee trained, which improve sparsification without compromising performance. So we're about to go very technical. These are all things that we could potentially do entire 1-hour events on, but we're going to go end to end today and cover a lot of ground. So grouped query attention, the TLDR on this is classic multi-head attention is pairing query keys and values. Grouped query attention is taking a couple queries and grouping them with key value pairs, whereas multi-query attention is sort of using the same key and value for many different queries. So it's a nice sort of in-between trade-off from the two extremes here. When we talk about ReLU², this is something that came out of this paper, ReLU² wins, discovering efficient activation functions for sparse LLMs. What they did is they looked at sparsity and performance, predictivity of sparsity, and hardware affinity. And they looked at ReLU, SWGLU, ReLU, and ReLU². Again, there could be a lot more that we talk about on this. But what I want to do is I want to kind of bring Lucas and the Wiz up to talk through exactly the structural modifications here. So, you know, Lucas, the ReLU² here is coming in on feed forward layers. This is obviously a very mid diagram because it's not just only stack.
That's
but
funny.
The idea is like the feed forward is where we're getting that function. The attention layer is obviously where we're getting the group query attention. Walk us through why you sort of made these decisions and why you felt like they were, you know, a step in the right direction in 2025.
Yeah, it's interesting. We have a variant, an architecture that is still a decoder only, but that had a ton of modifications. A lot of those being efficiency and like downstream performance based. And what you have to make trade-offs, because what might work on a single GPU node for testing, when you start distributing this across hundreds of GPUs at train time, when you're actually doing the pre-training, a lot of those architectural tweaks need a lot more help from kernels, and it can become rather difficult to ensure that those work at scale. So the ReLU and GQA kind of are the ones that we really wanted to push for, and that we knew we could do in a distributed run at this scale. GQA is primarily an efficiency play. We've found that we're able to get, you know, as opposed to just like your stock attention mechanism, we get at least 2 to maybe even 4 times the memory efficiency when you're looking at KV cache in particular. And this has been proven at scale. We're not the first to do that. And then ReLU we like to do a lot of stuff after we've trained models. Like, we love to treat these models as pieces of software to be manipulated and examined and experimented with. And having something like ReLU in the way that it deals with sparsity allows us to do some pretty fun stuff later on, as far as you can turn this thing into a sparse MOE of sorts without doing any kind of additional large scale retraining. And you can even down cycle it, right? So that it's not upcycling it into an MOE. We can actually take the current model now and turn it into an MOE of sorts at the same total parameters. So ReLU was, we didn't see any meaningful performance increase during our ablations, but we also didn't see it get worse, which is important. And it was almost like a play of saying, like, hey, if we do this now, we have the opportunity to do quite a lot of fun stuff with it in the future. So ReLU is kind of future-proofing it in a way.
Okay. Wiz, I wonder, can you double click into this like MOE of sorts through ReLU for the audience here? Because one of the things that's interesting from the blog is it's not a reasoning model, but it's good at reasoning, like so many things that are coming out today.
Yeah, I mean, at the end of the day, it's just how you do your best to, condense some of this, additional capability that you can find through MOEs into a small, dense network. The idea that we should have the ability to attend to tokens in a slightly more robust way, I think is integral to getting these like reasoning without reasoning models. Again, we've entered the murky swamp, right, in terms of where we're drawing the line now between what is reasoning, what is not reasoning, right? Because again, so like chain of thought prompting, right? Is that reasoning or not reasoning? Results unclear. And oftentimes we're conflating this idea of reasoning with test time scaling or test time compute. And so this model, as in AFM, doesn't seem to have any particular incentive to, as in, it's not going to produce thinking tokens, but it's still, you can still use techniques like chain of thought to encourage it to think through. And you'll see in a demo that Arcee's default kind of system prompt does encourage this behavior, but it's not like it's trained to waffle through 6,000 reasoning tokens or thinking tokens, then produce an answer. So it's when we say reasoning model, it's getting a little bit more murky. What we really mean is, can it tackle traditional reasoning domain problems as well, right?
Yeah.
And I think that AFM is like some other small models. AFM is doing this on the track to doing this in a way that is not going to explode your token budget. But of course, exploding token budget, such an easy way, right, to nail some of these problems. So
that's right. Okay. So Lucas, I mean, in terms of structural, like mods that make, a model sort of, let's say, better at reasoning, is that what we're going for when we say sort of MOE like, or what are we going for exactly here? Is it towards test time compute and reasoning, or is it towards some other,
Yeah, I mean, I think any kind of efficiency and inference speed up play definitely lends itself towards being useful for, if you're looking at kind of what the Wiz was talking about, where you're talking about like a reasoning model that uses like, it has like a thinking period where it puts all its thoughts in there. When I mention, when I speak more towards MOE like, I'm talking primarily around inference efficiency. So there's quite a bit of work you can do with ReLU in your inference platforms to like take advantage of that sparsity and really speed up inference compared to other models that are using just something like SwigLu, where it's firing basically through every FFN. But to this model, this version of AFM, we wanted to be a pretty solid non-chain of thought-esque model. We didn't do any RL towards thinking. There is quite a bit of reasoning traces in the data that we used for context extension. We distilled from R1 and the larger Quen model. So if you tell it to use thinking tags, it will do it actually quite well. We are planning our own kind of, we didn't want to do like a hybrid reasoner where it had, you could tell it to think or not think. At scale, that becomes very hard to keep that behavior while also improving performance across the board. You even see in the latest Quen models have made those like discrete models. You have a reasoner in your instruct version. So we have a reasoner version coming that is RL'd specifically to do that. But this one is just it should do well on 80% of tasks out of the box.
Okay, so if you do fast inference, you're setting yourself up better for more test time compute.
Yeah.
Okay.
I think something I just want to make sure that we don't miss through the weeds. Of what Lucas is saying, because he's saying a lot of really, it's dense.
It's very dense, yeah.
Which is great, but like this has been shown time and time again that doing the effort now, right? So as in AFM, 4.5. Be the instruct version of the model, like doing the effort now to give a good solid base of let's call it reasoning aligned capability, right, as opposed to saying like literal training for the task, like does make the model better downstream. And so doing the hard work now, right, not setting aside the fact that inference is obviously crucial, making sure the model has a good base to work from in terms of its capability on these tasks is so important. We see time and time again, right? This is why we have so many companies that have to go through this really extensive like SFT, or knowledge distillation phase to even start getting good results with things like RLVR, whatever flavor of the month RL you want to use. And so having that capability baked in, and we see this with the model like Kimi K2 as well, right? Having that base that's like competent is going to make your downstream training so much more effective. Again, talking nothing of the inference side of the equation. It's just having that capability to begin with. It makes it so much easier to encourage or foster increased capability once you enter the phase where you really want to now. Okay, we're thinking about this deeply. We're going to make the model much better at this. And this is not a new pattern, right? We saw this before where we have a base model that's seen the kind of data that we want to then eventually instruct to. And like it's the same, it's all the same pattern, right? That we've been following. It's just it's nice to see this in such a tight package.
Okay.
Yeah.
Okay, let's get into then exactly a little bit more of the pre-training info. We'll keep the discussion going in just a moment, guys. Thanks for your insights as always. All right, so when we talk about the pre-training phase of the AFM model here, what we want to do is we want to kind of think about, first of all, how many tokens was this thing trained on? And first of all, 8 trillion is like a bunch of tokens. And this is all before they're doing sort of what we might classically call post-training. So this is through the pre-training and the mid-training parts of the process here. So they worked with Datology AI to curate this data set. And that was a really important part because, as I said, they put sort of tremendous effort towards this idea of not getting into any sort of murky copyright waters, unclear licensing, just like keep away from that hornet's nest. And this is really, this sort of American-made model with really, really clear copyright laws aligned with the things that a lot of us care about. This is kind of part of the key goal here amid these 8 trillion tokens. And so the sort of result here, fewer hallucinations, better factual accuracy and a much lower risk, importantly, of IP issues. Additionally, not only is this thing pretty good at English, but it's good at a lot of other languages. So they tested across Arabic, French, German, Hindi, Italian, Korean, Mandarin, Portuguese, Russian, Spanish, a lot of languages here. Strong performance in each of these. And, this was just part of this larger effort to build a model that really was sort of, leveraging all of the best techniques and really getting great performance across a kind of generic swath of the way people might need to use these models. And importantly, adding really any additional languages, doing this kind of customization. This has been something that Arcee has been working on since we met this company, and they kind of were talking about building small models and customizing them for customers. This has been a key point of the work that they've done. So I'm kind of curious because this is something that we don't often see. Lucas I'd love to start with Lucas here. Like, is it like, this is something we get asked in class a lot. Hey, can it do this language, that language? Is this something that is now like officially, like you just can't build a model without multilingual support? And can you talk about what that customization process would be for other languages for domain adaptation?
Yeah, it's definitely not. Well, table stakes, I think having something that can be proficient at the vast majority of the languages that the population on Earth speaks is very important. Table stakes, as far as like, is it easy to do? No. I mean, that was one of the nicer things. Well, not nicer. It was a nice discovery about AFM was that our goal with the pre-training data and what we worked with Datology on to curate, and a large portion of that is synthetic. So to give you an idea of that, 6.5 trillion pre-training, about half of that is synthetic data. And we wanted the best possible model, and it doing well at those languages was just kind of like a nice find. And the whole goal with AFM, as to what you're speaking towards, is like, we wanted a model that was very easy for us to take and then like make it really good on some hyper specific downstream task, whether it is training it to do better at a language that maybe it didn't see as much during pre-training, training it to speak in a certain way within Arabic is notorious for having many, many different dialects and speaking patterns within that broader language. So it's definitely something you need to have. But I also think that, in our next AFMs, it'll be, however good it is in multilinguality now, we could probably go about an order of magnitude better in the next one too. So it's definitely hard. It's definitely hard, especially when you have a majority English speaking team.
Right. And can you also talk about the 8 trillion tokens and exactly kind of where you found some of those? Like you said, half of them were synthetically generated.
Mm-hmm.
Talk a little bit about the curation process that Datology AI went through and how they helped you out.
That was a really, I have to shout out Datology, and I'll be their biggest supporter till the end of the earth. That team is unbelievable, both talent wise, the way that I've really felt like it was a partnership with them. It wasn't just I pay you money, I get data. It was really a very thorough and intricate partnership where it was basically like just adding a bunch of really powerful data scientists to my team. With this one, we found that after running it through all of the curation, so part of that is synthetic, right? Which isn't like what you would typically think of synthetic data in the realm of what people have done in open weights for a while, where you take a larger teacher model and then try to post-train a model into talking like that one, and hopefully you get some downstream benchmark performance. This synthetic data is mostly about trying to denoise a lot of what you get in pre-training data. The internet is inherently rather chaotic. And also knowledge, making the samples you're training on more knowledge dense, right? So if you have, something that is 5 pages long, how can you try to rephrase and condense that into something that's 1 page as long, but still contains the same amount of information? There's also quite a bit of rephrasing that goes on about how do you make something teach reasoning, like inductive reasoning, just by the way that you format that. So the synthetic data is not, taking a teacher model and trying to make the model better. It really is, how can we make this as easy for a model to learn as possible? And then for the parts that weren't synthetic, that really was curating pre-existing data, we found that if we were to take something like FineWeb or Nemotron or DCLM, for every 4 tokens or so we put in, we got about 1 out that we were happy with and ready to train on. So a vast majority of the process too is taking a lot of these pre-existing data sets, and then how can we curate out the tokens that are most useful for our downstream tasks too. So that's looking at what do we want the model to be good at, both evaluation-wise, personality-wise, behaviorally, and ensuring that you have ways to filter and curate that from like a much larger corpus. So it was all in all, it was about 2 months between deciding what we wanted to do and then having that data set.
Yeah. Okay. So Wiz, he name dropped a couple of data sets. I wonder if you can maybe provide some context here on like standard data sets that people are using for these larger models today that are being trained, and like where we really need synthetic data. And then maybe Lucas can comment too, additionally, on where they focused on generating synthetic data. Like, what are some best practices in the industry today for this?
Yeah, I mean, Lucas has already said the correct answer, which is curation, right? So the reality is that when we first kind of started our beautiful journey, into pre-training, we cared a lot about volume and just getting more and more and more and more tokens. And of course, classically, we train on internet data, right? So internet scale, and also from the internet. Internet is not a curated place, right? Like it's very noisy. A lot of the data is not something that you really care to train on. And there were we've gone through a lot of phases about how we feel about pre-training data and what the quality of pre-training data has in terms of impact, right? So we went through some phases where we thought, well, it'll all squish out in scale, it'll all squish out in whatever, post-training we're going to do. But the idea of taking these huge corpuses, which we have, I mean, there's so many now, kind of data sets that are, well licensed or at least like transparently licensed, that have accurate licenses, more importantly. And then, our ability to curate has also gotten much better, right? So the ability to filter through to find this quote unquote high quality data, whatever our metric happens to be, has gotten a lot faster and a lot more accessible, and costs less. Like, I know the way Lucas described it.
Yeah.
It took 2 months, right, to curate all this data. Like,
easy.
I imagine us back in 2022 saying it took 2 months to curate, this massive data set, and it would be like, that's insanity, right? Like it can't be done that fast. And that just speaks to kind of how far we've come. And I think too, people are coming around to this idea that like the data quality in pre-training is important, and we're not just going to squish things out with scale. This is no longer quote unquote the wisdom, right? And I think we're seeing that move or motion toward, okay, fine, we're gonna have to pay the cost to actually care about like what we're putting into this machine. In terms of like how to curate, I mean, there's 1,000 ways to do it. I'm sure Datology has a great practice for this. Lucas is speaking very highly of them, and the data set, results in a model that's great. So, and then in terms of specific data sets, there's too many to count. But the idea is it really depends on where you're trying to push the model and what capability you want the model to exist in.
Yeah, so maybe that's the point here, Lucas, is like you got the buffet of data from Datology. They're like, hey, welcome to the buffet. You walk into the Chinese buffet. What do you get? Right. Or let's say the American buffet in this case. Like what are you choosing and why exactly? We're not hearing you say common crawl. We're not hearing you say sort of these, generic things. Like, what are you looking for? Or are you kind of outsourcing it to the Datology team to say, tell me what the best practices are from you guys' intimate work on this? Like who's the expert on this,
The expert's definitely Datology.
Yeah.
And that's one of the reasons I went and worked with them, is I think when we decided that we wanted to commit to training our own, there's a few ways we could have gone about doing it. And I am very comfortable saying that we are some of the best ragtag group of model post trainers in the world. We have the data to back it up. We have the pipelines to back it up. Like, that is where we excel. So what we needed was one of the best base models in the world for us to start from. So I knew that, if we tried to do all of our data work in-house, and we wanted to do this on an accelerated timeline, right? Like, we didn't want to take a year to be doing smaller scale runs and many ablations and then training our first model and then getting better based off that. We wanted to kind of reach the frontier of this size model on our first try, which was ambitious. I knew I had to go to the people that I thought could help me get there. So while it wasn't like, hey, this is what you want, here's what there was a very large discussion around where we were starting from. Were we going to go the common crawl route, right? But that ratio is even higher, right? So if we went straight from common crawl, for probably every 10 tokens we put in, we'd only get one out, which that means to get where we wanted to be, we'd have to put in like 80 trillion tokens, which is not feasible and also very hard to find, and very expensive. So it was a lot of work around what do we want it to be good at? What are the kind of downstream use cases? We wanted it to be very good at like knowledge retrieval and knowledge retention. Reasoning was an important one, though. An interesting thing that happened was we had been discussing and ideating on this model since late December of last year, and then really having serious discussions internally and externally around the end of January. And that was kind of like when R1 came out. And it wasn't until March where people started to realize how important it was to have a base model that was good at doing reinforcement learning. Like you can't just take any base model and then not do any kind of warm up and then expect it to do well, especially on reasoning related training. And we were already very deep in the weeds on curating this data set at that point, because it's not just like, okay, press a button and you curate the data. There's a tremendous amount of infrastructure work that goes into it as well, because we're having to host and run and do many different models that are generating this data and then rephrasing it, and then also the pipelines and embedding and classification models required to do that curation. So just getting that set up in a way that it was reliable and was going to work, I mean, that takes a tremendous amount of time. So it wasn't, we did a preview release last month.
Yeah.
We didn't open the weights. And then it was about a month between then and when we released it open. And that was because we wanted to go back and do some extra training, some extra part of that mid training to be sure that it was really good at RL. There's a tremendous amount of work that goes into that, that none of the labs really talk about, because, that's secret sauce. So that is by far, going into our next run, will be a tremendous piece up front, is ensuring that is like priority number one, is being sure that these things are good to RL from the get-go, and we don't have to do an extra 1 trillion tokens to get it there.
Okay. Let's stick with that idea of mid training and just stay up here with me, guys. So we got this, you said warm up too. We've got to sort of warm this thing up. And so this 1.5 trillion tokens for mid training, this is the line from the blog, followed by 1.5 trillion tokens of mid training with special emphasis on mathematical reasoning and code gen. Then after this pre-training, mid-training, we're getting into the post-training. So like this idea of training, this is part of this warm-up you're talking about, making it better at reasoning in the base that you're talking about, this is part of the reason, like, last time we talked with you guys and you released a model, it was the Supernova model, and you picked Llama off the shelf, but you didn't do that this time. You built your own. Like, is this all connected? That sort of DeepSeek sort of set the new tone here of the industry. Is that kind of, is that a narrative that works for you?
We definitely want to be a self-sufficient lab, that when we're delivering things to customers, we have complete control over the stack. And one of the things that has been found over the last 6 months, and I think deep research from OpenAI was the first glimpse of this, and it's only continued, is deep research was like the first agentic experience that I would say really kind of had people go, oh, okay, like this could work. The only way they were able to do that is they built the environment, and then they did reinforcement learning towards that on top of O3 to be really good at deep research. And so we strongly believe that the way to make these agentic systems and experiences work at scale and with reliability is you have to be doing RL over them towards that task and in the actual environment they're going to be working in. And you're only able to do that if you own the model from pre-training, mid-training to post-training. When it comes to mid-training, mid-training is, the definitions are all over the place. The way we ended up using it was as a part of the learning rate scheduler we're using. Right at the end, you do a very, not quick, but you do a pretty drastic decay, a pretty big anneal. And as a part of that, that's where you're kind of getting your models soaking up a lot of information, and you're getting kind of a little bit more training performance per token. And so we put the data that we had the least of, that we really wanted the model to be good at, in that phase. Getting math and code data that is A, high quality, but B, like permissive and then accurate, is extremely hard. At that scale. It's very hard to get, and there's actually quite a bit in that mid-training data that is repetitive. Like we did many, we might have taken, a data set with 10 billion tokens and gone over it 4 or 5 times.
Yeah.
So that was what we used mid-training to get, what did we want the model to be really good at towards the end. And math and code, we also threw in a bunch of reasoning traces as a part, and we also threw in some instruction data as well.
Oh, okay.
So that's where we're trying to really, that's the most important thing for getting these models capable at RL, especially when you're doing them towards like verified rewards, is getting them really good at speaking the language of RL, which right now is math, code, science, that kind of stuff.
Okay, so Wiz, are you okay with like a definition of mid-training being like the phase after pre-training where we focus on preparing the model to be good at RL and reasoning, or something like this? Like what?
Yeah, if the question is, am I okay with mid-training being defined as what comes after pre-training and before post-training? Absolutely, yes. I think it's some of the words that Lucas is using are important here. So we have this idea of like the DeepSeek, cold start or warm up or whatever language you want to use. We've been doing this the whole time, right? So we've been this SFT and then XYZ, SFT and then ABC. We've been doing this the whole time. It's just now we're understanding that preparatory work, building the foundation, on top of the foundation, right? So we lay a base layer down, we pour the concrete, right? But now we need to build a house on top of it, and that requires having spending a lot of effort making sure that you're all of the scaffolding you're doing, all of your the studs are in place, that they're tapped into the concrete. Like all of this is important, or the house will fall down, right? Before you can start then putting drywall up and then painting and adding plumbing, right? Adding electricity to the house. But spending a lot of effort in mid-training, and also I think kind of grouping the effort together, which is something that I think is more commonly practiced now, where it's like, okay, we know the model is going to go through this post-training stack. And we know that in order to go through this post-training stack most successfully, the model has to have seen some of this stuff before. It's got to be, like Lucas said, it's got to be able to speak the language of whatever post-training flow you're doing. And so spending a specific concerted effort in that phase for your post-training stack is important. You know, you can think about it like this. If we're going to use a specific set of post-training techniques, if we're going to go through the effort of maneuvering our model to some desired final state, and the stack we use now is much more complex, then by necessity the preparation on top of the base model must also be match in some way that complexity.
And I will say very quickly that like our goal from the beginning was never for this thing to be a beast at math and code. If you're going to be doing mathematical reasoning and like large scale code generation, you need a bigger model. That's just not what these are meant for. I wanted this thing to be really good at like knowledge retrieval, really good at, retrieval augmented generation, summarization, classification, rewriting. It was actually initially meant to be an on-device model for a phone. It just ended up being stronger than we anticipated. But we found what the bitter lesson there is, like, if you're trying to do any kind of RL, even not, again, reasoning focused, but, you're trying to use reinforcement learning to improve it. Big one for us was instruction following. It needs a ton of math and code to start to even be good at that, which is like the most fascinating thing. So that was why we did an additional trillion between last month and now of just math and code, because that was, even if we're not doing RL towards math and code, it needed that. It was really fascinating.
Okay, so just final thought here. Yeah, go ahead.
I just want to make sure. So this has been shown time and time again, right? So we have this idea that with things like SFT, we sometimes find the model kind of falling into traps or pitfalls, or over-indexing or over-focusing on those domains. But one thing that's true is once we enter this kind of RL domain, which is inherently much sparser than something like SFT, we do find that this generalization capability is flatly improved by including things like code, like math. And actually, if you recall all the way back to when we just started instruction tuning, right? When we were coming out of the mud, right? The primordial soup. We found that like training on like Python, right, made our models understand natural language better, right? Made our models understand normal speaking language better. And I think this is the same. We're seeing the same thing. We're having that hyper structured example of what can be done is very good for generalizing later, right?
It makes sense, right? There's like a mid language that sort of exists between us and the LLM, and it's the way we write code today.
Mid training before RL even became the next big like scaling paradigm, like mid training was mostly taking massive amounts of SFT data and then just going over that without masking out the user role. Like it was just annealing over tons of instruction data in like the last 10% of your run, so that the model was really good at being instruction tuned later. So yeah, mid-training just preparing it for post-training, frankly.
Okay. And as the ragtag group of bandits that aim to be one of the best in the world, if not the best in the world at post-training, mid-training is an essential step to prepare for that. Absolutely. And that's part of the reason you want to own your whole stack. Okay, perfect. I got a quick intro to the post-training, and then we've got to cover post-training pretty quick here, guys. All right. Let's talk about what we know about their post-training pipeline. This is where it gets crazy. As Lucas mentioned, this is what they spent a lot of time on. After pre-training and mid-training preparation for post-training, we performed supervised fine-tuning using high-quality instruction data sets, a classic. Then further refine the model with RL using both verifiable rewards and human preference signals. So when we talk about post-training and we talk about using verifiable rewards, and we talk about some of the lessons learned from DeepSeek, we're often talking about group relative policy optimization. We're talking about this idea of how we can actually just see the reward signals and use them instead of like really having the human in the loop or the AI in the loop, whether we're doing RLHF or RLAIF. And we have covered this on previous events in more detail. There's also an additional method that they did use that's quite interesting here called KTO. We had a question on DPO in the chat. This is in the same vein here, where the model is learned from sort of trusted reference behavior. And interestingly, this KTO, this from February this year, this is kind of rooted in that system 1, system 2 thinking that we know so well from thinking fast, thinking slow, from thinking about reasoning models and distillation. And the key insight here is that humans are famously loss averse. And so the idea of using this different kind of family of loss functions approach, these human aware losses, these halos, is kind of the core insight here in the KTO process. But there's a ton of stuff going on here. And so I want to give a few minutes here to Lucas to walk us through, like, so the thing's ready to rock. It's done mid-training. You're ready to get into this post-training. So you guys are like, okay, this is our special sauce. How do you think about cooking this thing up from here? Instruction tuning first, and then what? And then where do you get into that sort of R&D space again, where you're not quite sure exactly what to do? And what have you learned?
Learned a ton. And I mean, it's the RL paradigm of especially GRPO and doing not just preference related RL like KTO or DPO has changed the way our post-train pipeline quite a bit, because what we used to love doing was we would take a model, if we wanted it to be good at 5 things, instead of taking all of those 5 things, putting it in a massive data set, running the model over it and hoping it was good, we would train a version of the model on each of those things at a time. So we trained 5 different models. Then we'd use MergeKit to try to ensemble as much of those performance gains into a single model, try to get something that was really good at all of them. And then we do some form of RLHF, eventually moving to KTO at the end to kind of further align that merge. Not from a, safety alignment standpoint, though that's definitely part of it, but just to even out some of the rough edges that can sometimes come with souping models at that level. And once you add in RLVR, and again, we did a bunch of reinforcement learning on this train. It just wasn't, as to what Wiz was talking about, it wasn't reasoning RL. It was just using verifiable rewards to improve. Again, the biggest one was instruction following and a little bit of human preference optimization. But you can't just willy-nilly do RL and then merge. It creates very sensitive models, and it's very hard for you to build out, okay, we want it to be really good at this thing. We need to do RL probably towards the end to be sure that it's good at that thing. Therefore, you have to plan your post-training a lot more granularly, and it has to be a lot more targeted. So we did around 3 to 4, it was about 3.5 billion tokens worth of like your standard SFT instruction tuning, with a massive emphasis on like multi-turn data. So not just like single back and forth, but like whole conversations. We trained basically at the whole 65,000 context sequence length we had for those runs. Then we did some merging, but mostly as like almost like a normalization step. Like it wasn't taking 3 different models that were all good at one thing and combining them. It was very much you do just get benefit from merging even the same model that maybe have slightly different hyperparameters in training. Then we did our RL after the fact, which was GRPO towards, again, instruction following, a little bit of like Python and mathematics, just to bump up those scores a bit, even though that wasn't, our main goal. So I imagine when we chat again in a couple months and there's another model, our post-training pipelines can be very different. It's also gonna be different in a couple weeks when we release a reasoner and an agent-focused one. There's a whole, it's very different for every single run. It's very exciting, but but it is definitely, it's a very different ballgame post-training.
Yeah. So just, I mean, a quick follow-up there. So if you were going to do the reasoner now, and presumably this is already on the roadmap, you just told us, but like, where do you start? Do you start at the mid-training point, or do you do different mid-training too? Or the mid-training is pretty good?
I don't think we'll need to. I mean, we did. So outside of mid-training, we also did context extension. A lot of people do that during mid-training. We didn't. Our context extension we did using DistillKit and MergeKit. And the way we did that was we took massive amounts of data and logits from models like R1 and the new Qwen 3 MOE, and we distilled those into the model, going from 4,000 token sequence length all the way up to 64K.
Yeah.
And we used Yarn for that. And that process was very difficult to maintain performance that you have at those smaller sequence lengths from the mid-training once you extend it to 64K. So it's already pretty warmed up for RL. Again, as I said, like if you put thinking tags in the system prompt, it will do it. We're putting into a little bit of an SFT warm up just to get it talking the way we want, and then we'll go pretty full scale RL. Now there's a debate as to whether RL is even worth it at models of these sizes. Our findings show that it is.
Okay.
So I'm excited to share that.
Okay, cool. All right. And then Wiz, we were just talking about this the other day, the idea that, you can't just do RL on a bunch of things. You can't just do super duper fine tuning and then smash them all together. And it's interesting that they sort of, found this in practice. This appears to be something that intuitively wouldn't make sense, and in fact doesn't make sense to do. And,
I mean, one of the things that, again, just to highlight from what Lucas is so much excellent information there, right? But one of the things I want to make sure we highlight is this idea that like each pillar of your post training, right? So on whatever capability you're talking about, instruction following, chat, reasoning, whatever it is, they all lend themselves to different techniques. They all lend themselves to different methods of training. And this is something that we didn't care as much about, I would say, in the years past, that we're caring a lot about now. So when we have these post-training blends, like they're very, tailored to the actual thing that we're trying to produce, the result or outcome that we desire. And that's extremely exciting, right? Because it's not just like we have one Swiss Army knife that does okay on all these things. It's like we have a Swiss Army knife that has specific, tools for each capability that we desire. And you see that this is very true in a lot of the recent releases from Qwen, Nemotron Super that just came out. All of these models use very specific pillars, right? The other thing that I want to make sure is clear, just because we've got Arcee with us today.
Yeah.
Like merging has become such a ubiquitous part of post training. I think we don't talk about it a lot, but like everybody is merging. You may not, it's not like the highlight of the paper, right, is going to be, and then we merge, but they do. And then we merge, right? We have these XYZ checkpoints, and then we merge them together because that's the best way to train models. And again, it doesn't have to be like what Lucas is describing they avoided. You don't have to train 5 separate models, suit them together, but you are going to train some number of checkpoints, and then you are going to merge them together because you get better performance. And this is even more so important in the kind of sparse training that we're doing these days. But yeah, I mean, it's no longer one size fits all for post training, and we're in such a playful, exciting space.
Yeah, it's really fun. It's really fun.
Yeah, and I didn't hear you say AGI or ASI one time. Not today. Okay, so yeah, we're actually aiming at specific things now, which is great. All right,
AGI by 2027. Yeah.
That's right. 100%. 2030 at the latest. Yeah. All right, so let's get Wiz. You got a demo for us? You're going to show us the models.
Yeah. So you know what? This is perfect timing for this demo. We're just going to very quickly go through some stuff. So we vibe check the model effectively is what you can think of, and because you've got to. We wanted to showcase some of the things that the model is good at, as per the claim that Arcee makes versus what the model's actual capabilities are. So this is not like detailing their training process, just using the model and showing off what it's doing. This is my favorite part of the model. So the fact that there's curated data is very interesting. It's very new. Something we don't talk about a lot in this space is that like everyone's been using the same pre-training blend or like a very similar pre-training blend for a very long time. And so the models actually kind of feel similar. And I wanted to see if Arcee's felt a little bit different. And so we have one quote unquote test. It's not a real test for that. Using the model is easy and it's small, 4.5B. You can run this in the A100 instance or the L40 instance on Colab, and then they offer quants, so you can run it on the free Colab instances as well. Of course, you can see all of their quants on their in their organizational Hugging Face. Loading it up, we haven't done this demo in a while. This is loading up with transformers, right? We load the tokenizer first, and then we load the model up. Very cool. This is the instruction tuned version. This is like the post-trained version. This is not the base model. Vibe checking the model. Obviously, these numbies are good. These are good numbers, especially compared to their other size friends. Of course, I think it's less about these numbers. Something that I personally very much like about Arcee. It's something that I also like about Anthropic. You have to put benchmarks up and you have to do well on them, but it's more about like what the model can do and less so about, we're like benchmarking on these specific scores, which is very nice. So the model feels good to use. Let's start with a test that the model probably shouldn't do well at and also doesn't do well at, which is Simon Willison's, of course, Pelican on a bicycle. It does draw what could be described as a bird, if we stretch our imaginations. The thing that I do like about this result, though it's obviously not a great pelican riding a bicycle, the model does correctly identify that the pelican should be dark violet and yellow. So there is some understanding of the fact that the colors are correct. Models that are this size sometimes fail this and have no idea what they've produced. And so that's heartening, at least. This yellow is going to come back in just a moment. Ours in strawberry. You got to do it. It's not a reasoning model, but we know that reasoning's in there somewhere. And so we do the R's in strawberry. It nails it. It gets 3 R's in strawberry. You'll also notice that the system prompt has this chain of thought style, injection. So it is capable of this step-by-step thinking. Interestingly, it gets it wrong, or it gets it correct for the wrong reasons, believing that strawberry is spelled straw raw brie, which is of course, who cares? 3 R's, it's correct. Let's not look too deeply into it. But this is not a reasoning model. It's 4.5 billion parameters. Other models at this size fail. Even reasoning models at this size fail. So this is good to see. This is the kind of base that I was talking about earlier that you have to start. And then Lucas, tripled down on. You have to start with a good base in order to do these tasks well in the future. Legal acumen. I'm not a law guy, but the model is purported to be decent at law. So I asked a question about what constitutes a search. As you can tell by the quotations, this is from our friend O3. I did get a lawyer to verify this. This answer is in his reading correct, which is good. But basically the idea is that, does this constitute a search? Yes, it does. And that's in congruence with the law, as I, not a lawyer, believe. And then it says Arcee claims it is good at writing 2-sentence horror story, it's good at creative writing. And so we give it the old creative task of 2-sentence horror story. And it kind of does a banging job. The old house creaked as shadows danced across the walls, but it was a silence that chilled the bones. No creaks, no whispers, just an oppressive stillness that felt like a living thing. It is 2 sentences, and it is horror. Great job. And again, it's good at both of these things, which is nice, especially considering the model is quite small. And that's great. Finally, my favorite test for new models is trying to figure out what its favorite color is. This is something that a lot of models have internalized, right, through using similar pre-training blends, and they mostly land on this kind of weird blue-green. But as we see, Claude 4 Sonnet, we're on the green side of blue-green. O4 Mini blue, small LM3 blue, DeepSeek blue. Nemotron super blue, AFM bright yellow, baby. So this is not a rigorous test, but I love seeing this. This is interesting. Does indicate that there's some special sauce in that data somewhere that makes it put bright yellow, which is great. And then the base model is a base model, and it acts like a base model. I'm already way over time, but it does the thing. It generates tokens in a sequence. We love to see it. For me, the important thing is that they released a base model. Clearly, this is something that we want to build on top of. This is a model that people are going to build and specialize on top of, and having access to weights for both of these stages. One, the actual base model, and the other, let's call it a mid-base model, right? That's ready for RL, that's suited for that for further post training, is dope. And so with that, way over time, we'll pass it back to Greg. Before I do though, please ring the bell and subscribe. We're here every Wednesday. We look forward to having Arcee and Lucas back on as they continue to innovate in the space. Love these guys. Okay, there you go. Back to Greg.
All right. Thanks, Wiz. And we are ready to wrap up. One quick note after we've just test driven the model there is, as long as you don't make over 1.75 million a year, you're free to use this thing however you'd like. And so it's kind of an interesting licensing approach, and really still very focused on the open source community, which we also like. We've got a great number of takeaways from today. There's just so much packed in here. You know, these guys are the post-training experts, and we'll continue to have them back to tell us about their learnings along the way. They made some structural updates, thinking about mid-training and this preparation for post-training, really warming it up, doing this annealing, thinking about how, you know, deep research started by taking O3, and then from there, this idea of sort of preparing the model for what it's going to do next is just really important. And that post-training stack, just so epic. So we've got a couple questions. Thanks for sticking around, guys. I'd like to run through. First, Lucas, this is related to one of the questions in the chat. Like, when should we use this model exactly? You know, Wiz just showed us a bunch of kind of, you know, peppered examples, and there's a question sort of about specific use cases from Chris Fu. What are your customers doing with this, and when should individuals like our audience pick this up off the shelf?
Yeah, the post training release yesterday, I think anything you would have used like Llama 3 8B for back in the like this will do not just well, but in a lot of our testing, it'll do better. Mainly targeted right now with customers is not every single coding. I mean, AI task right now is like coding and math. There's a tremendous amount of summarization, classification, rewriting, and like background tasks that should be done by a smaller, cheaper, faster model. The big one this one's really good at is RAG. It can do really well with retrieval too. So if you're looking for something on device, cheap, fast to do retrieval over your data with, I don't think there's a better model in this size class.
Maybe it has a role in the next boot camp for us. Yeah. You know, better and faster and cheaper. Llama 8B. Okay, love it. There's a question here also on regulated industries like healthcare, finance, legal. Have you tested this for sort of domain accuracy, or do you work with clients for additional post training?
Yeah, we do. I mean, that's post training. Like that is where the customization comes in. It is rather good. I mean, it's from a compliance standpoint and like data leaking and that level of accuracy and like safety, it's rather good. But when it comes to working with a customer in a highly regulated industry, that is one of those where we're going to make a task-specific variant of AFM just for them.
Okay, cool. And then finally, you got a shout out before we close out today. You're hiring, right? The team is growing. So tell us about that. And I know our audience would be particularly interested.
Yeah, we're bringing on, I at least have room for 5 more researchers. So as we look at scaling this up, we pulled this off with a team of 8 researchers, but it's really 4 of us who are in the weeds. Our competitors have many, many more than that. And to accomplish our ambitious goals, we need some more people. You know, we're looking primarily for those with an academic background that are looking to get in early on a small team in the industry. We have a tremendous amount of our research talent right now is just like applied research engineers who intuitively get these models. And I think having augmenting that with some more academically rigorous people is going to be key for us. So
Okay.
I'm
So
always open to anyone,
Sure.
send me your resume, let's chat, but that's primarily where we're looking right now.
Either like PhD from kind of a leading lab, or if you're like Charles and you just built something like MergeKit.
Yeah, if you're just Charles, you're just insane. Yeah.
Yeah.
I mean, I don't have 100 million to throw around for comp packages.
Yeah, I was gonna say, is it 1? Is it 10? Is it 50? Like, what are the numbers here?
Let's chat. Let's see.
Yeah, let's chat. Okay, well, thanks for your expertise, Lucas. We look forward to having you back, man. And this has been a blast as always. There's not enough time to discover all the technical details.
Yeah, thanks for having me, guys. I appreciate it.
All right, see you, Lucas. Thanks, Wiz, for the expertise as always. It's time to wrap this thing up. Thank you, everybody, for joining us for another weekly Wednesday YouTube live event. If you're not yet part of our community, we are on a mission to build the world's leading community for folks who want to build, ship, and share production LLM applications, whether we're building the LLMs ourselves or just leveraging them and building apps with Lego blocks. If you liked this session, you'll definitely like the vibes in the Discord. I'd encourage you to hop in if you aren't a part of the community today. Next week, we're going to be talking with the team from TypeDef. This was an intro we got from the Arcee team about a new company that's launching, and they came out of stealth mode. Their product is open source. It's called Fennec. PySpark inspired AI data frames is the topic next week. We'll be joined by one of the leaders of that brand new startup, and we'll walk through their tool. And of course, this is the very last week that you will be able to get a early bird discount on the AI Engineering Bootcamp Cohort 8. We're going to kick off September 9th, but you can still get in 20% off, save $700, and do that through Friday this week to get in early if you are the early bird that likes to get the worm. And thanks again for joining us today. Until next time, keep building, shipping, and sharing. And we'll do the same. See you back next time. Same place, same time next week. See you soon.
But Greg, how do they get started building, shipping, and sharing?
Getting started is the hardest part, like it was for you and for me. You can get started with the AI Engineer Challenge, and you can share it in the Build, Ship, Share channel on Discord. Links in the description. What if they want to accelerate their ability?
Well, we actually have a 10-week intensive bootcamp where you learn to build, ship, and share production-ready LLM applications every single week.
The AI Engineering Bootcamp cohort starting soon. We'll have you building, shipping, and sharing
like a legend.
In no time. We'll see you in class.